welcome our first speaker, Oliver David Kreig, to go ahead and turn on your camera and start sharing your slides. Oliver is the CTO, Chief Technical Officer at Intelligent City, based in Vancouver. He also had the difficult challenge, I think, of finishing his PhD at the same time he was beginning work with a new company. When he showed me some of the things they're working on, I was very impressed. So excited to welcome you, and we look forward to hearing what's been going on with Intelligent City.
Thank you so much, Daniel. I hope you can hear me all. If not, let me know. First of all, thank you very much for the introduction. Thank you for the invitation. I'm really honored to be part of this session and the conference. So Intelligent City is a technology-enabled urban housing company. We design and deliver 4 to 18-story mass timber buildings as turnkey products by combining engineering, manufacturing, and parametric design all under one roof. A quick history lesson, because I think it's really interesting to note that the tools we use have always influenced how we design and construct buildings. In the pre-industrial era, manual work and tools led to highly efficient and unique building components requiring minimal machining, right? But they were also, all of these building elements used to be made specifically for a specific purpose in a specific shape. And so that uniqueness kind of got lost through the industrialization as it led to mass production and standardization. That obviously increased the potential output of our industry, but it also led to repetitive processes. And most importantly, to a fragmentation of our industry that has basically inhibited innovation for many, many years. Other industries have since developed technologies that allow them to introduce variability within scalable manufacturing technologies. However, and this is very important because I'm sure you have seen this picture, buildings are not cars. The term mass customization is misleading in that the main parts of cars are actually standardized. Building systems and buildings need much more flexibility and adaptability to become applicable on a larger scale and to really break through with the sort of platform paradigm. In my previous job, I worked at the Institute for Computational Design and Construction at the University of Stuttgart, where we explored the potentials of novel manufacturing technologies for construction and architecture in scale. We developed manufacturing technologies and ultimately in conjunction with design and structure, which led to many projects that showcased what an integrative approach in our industry could look like. What if we don't design only the design, but we design the design system, we design the manufacturing of the design system, and we design how we design as well. The journey of our industry throughout the centuries, I believe, can be seen as a negotiation between adaptability, sort of flexibility of design, the design system, and manufacturing intelligence, how manual, how automated, how ultimately intelligent and adaptable it also is. Recent innovation has opened up opportunities for platform-based design processes and automated manufacturing. That's no surprise. But the adaptability and versatility needed in architectural platforms to be successful is really still missing. At Intelligent City, we believe that instead of falling into the trap of one-off parametric projects or standardized industrial prefab, the future really lies in between, sort of in the convergence of high-tech manufacturing with a lot of adaptability and parametric design, which ultimately leads to scalable processes. And this is what we call parametric platforms. With the challenges we are facing today, it is really inconceivable why our industry has not yet found scalable and adaptable technologies to deliver buildings more efficiently, more affordably, and with zero carbon footprints. This is why Intelligent City has developed a parametric platform for 4 to 18-story mass timber urban housing projects. We combine 3 paradigms that one could say are were previously unfamiliar to our industry. A product-based design approach to develop the building as a product to make sure it is socially inclusive, affordable, it has high livability metrics. We focus on mid-rise densification because that's where we also see the biggest potential for cities to grow. It's a platform-based development process. It's infinitely configurable across building designs. It has pre-integrated design engineering, and it uses mass timber as a primary material because it's the most promising building material that we have and the only one that promises to be carbon zero. And we combine that with an end-to-end parametric process that also includes manufacturing technologies in order for us to be in control of how things are being manufactured. This is what we call platforms for life, transformative innovation through convergence. And I want to talk a little bit about all three of these aspects and how they sort of come together into this product-based approach of a building and how flexible it ultimately really is. The product is the result of over a decade or even 2 decades of experience in urban livability. The founders of Intelligent City have worked in this realm as architects for a very long time. And we created this product in order for it to be livable, to create a sense of home, to enable communities and inclusion. There are many design aspects inside of this DNA that we have developed. Compared to typical projects, our buildings provide more sunlight, more cross-ventilation. There are double-sided apartments. You don't have double-loaded corridors with interior bedrooms. And most importantly, they are just higher quality. They need less space. You can live, you have more livable area with less required infrastructure space in your building. And therefore, we can also have more apartments in a building without losing any of that quality. Our building platform is based on a number of parametric components. These are, most importantly, integrated double-layered floor panels that already include from the factory certain mechanical and electrical components, passive house envelope panels, all made from mass timber. So we create basically, most importantly, the core and the shell of the building as fast as possible, and it's completely made out of mass timber. The componentry is not a kit of parts. It is based on a range of grid spacing that allows us to adapt every building shape to various sites and needs. It enables, as you can see in the middle, this sort of flexibility. We can deliver small and larger projects with different shapes and different heights. This is sort of part of the design process, of the design system, if you want, within which you can navigate. But also most importantly, I think, again, the platform integrates the design philosophy in that a library of apartment types can be assigned to the building system. It is based on a certain grid spacing that is variable. You can include, 1 bedroom, 2 bedrooms, depending on how many grid spaces you want to occupy. But also, we try to make sure that the apartments can also be changed later on. If there is a change in the building life cycle, which surely will happen in 25, 40 years, you want to combine multiple apartments into a bigger one, that should be possible. That should not lead to the building to be demolished. Now, that flexibility can be designed by hand, right? It can be designed as a design system that you can act on in a manual way. But I think the keystone in order to enable all of this design philosophy and the ambition of a scalable process, you need a design tool that allows you to work within that flexibility, to navigate that design space and to get enough feedback. So we have developed what we call an end-to-end parametric software that enables this adaptable building system. Based on multivariable design, live database integration, we can optimize for different metrics like livability, quantities, cost, and carbon. In the digital design process, we basically interactively adapt the distribution of homes, different apartments, how the stacking works. And then a live link, like you can see here, the software populates all a design option with all fully detailed building system based on sort of all these building elements that we have previously developed. And then we create but this is basically, it's a virtual twin. We get buy-in from all stakeholders before manufacturing on-site construction commences. So everything we design is buildable. All system components have been developed together with advanced robotic manufacturing technologies, combining automation and adaptation. So this is off-site construction. It's obviously, as probably everyone who participates in here knows, it's faster and more precise and predictable. But developing the manufacturing technology in conjunction with our design technology and in conjunction with the designs that we can that we want to be able to deliver, that has been the key for this platform to be successful. So in one picture, we basically have what we call design engine on the left. We can run through optimization. We can try out different variations of a certain design. It's all parametrically or computationally, if you want, assisted, right? We're not replacing the designer, we're not replacing the architect. We are developing only a design system. If you want, we're developing a game, right? That we can play, but we are making up the rules. So in essence, we are augmenting the designer. We are giving the designer and ultimately clients and stakeholders the ability to properly make decisions based on information that this design system gives them. And I think that's very important because computational design or generative design, however you want to call it, is not here to replace anyone in this process. It's only here to assist us and to make us aware of the decisions we take and to empower us ultimately to make the right decisions and to concentrate on those things that are very important. So this underlying parametric workflow enables that, and it creates basically in the middle this full virtual model, but also that is simply an artifact that comes out of the design engine, and it transitions further into the entire building system in a parametric way, generating BIM information, generating shop drawings, fabrication data, and ultimately also data for our manufacturing plant. It comes, of course, with a very important mission. We have to build as much carbon neutral housing as possible. And by combining these technologies with mass timber, we can say that today we can already reduce annual GHG emissions by 93% compared to incumbent buildings. And in fact, our buildings can be carbon negative, even with a life cycle of 90 years. Intelligent City emerged over a decade ago with the first sort of showcase building. Back then, it was a modular construction and it didn't use mass timber, but that was basically the only difference. The design system has been developed back then, and we realized that if we want to deliver this on scale and with that flexibility in mind, we have to combine the design ideas with a parametric workflow in our own manufacturing. We have since worked towards commercialization and readiness. We are now basically just moving into our factory and installing the manufacturing equipment, and we're delivering, I'm happy to say, the first buildings already later this year. Our technology has always been developed to be scalable. So also the manufacturing process and workflows of this platform are part of the platform and can be replicated across multiple locations. We believe that in order to achieve a paradigm change in our industry and to ensure that the future of construction can solve the fundamental challenges of sustainability, affordability, and livability, we need integrated solutions such as the one as Intelligent City is offering. Thank you.
Thank you very much, Oliver, and for the great presentation.